We have a problem. Our environment is rapidly deteriorating due to the interventions of mankind. The sacrifices we make in order to live a more comfortable and convenient lifestyle will ultimately deplete our resources and damage ecosystems beyond repair. Much of this can be contributed to the after effects of big industry productions, which leads me to my topic. Society must find safer means of disposing of some of the byproducts of large-scale chemical reactions. Now, on to my first topic, acid rain. The primary cause of acid rain, more accurately called acid deposition, is air pollution from burning fossil fuels. Fossil fuels do not directly emit acids into the atmosphere. Instead, what it does, it emits large amounts of acid precursors, which are primarily sulfur oxides and nitrogen oxides. When exposed to the atmosphere, these react with water droplets to form sulfuric acid and nitric acid, which are components of acid deposition. Some of the effects of acid rain include acidification of lakes and streams, which lowers the pH level and thus makes it inhabitable for fish and other aquatic animals. So you can say goodbye to tuna. In addition, rain accelerates the decay of building materials and paints, which includes irreplaceable buildings, statues, and sculptures that are part of our nation's cultural heritage. And it also contributes to the damage of trees at high elevations. How to reduce it? You can use coal that contains less sulfur, which therefore reduces the amount of acidic precursors that come in contact with the atmosphere. You can also wash the coal using devices called scrubbers to chemically remove the SO2 from the gas leaving the smokestack. Power plants can also switch fuels. For example, burning natural gas creates much less SO2 than burning coal. Power plants can also use technologies that do not burn fossil fuels. And similar to scrubbers on power plants, catalytic converters reduce NO emissions from cars. These devices have been required for over 20 years in the United States, and it is important to keep them working properly. Recently, tailpipe restrictions were tightened to help curb NO emissions. EPA also continues to make changes to gasoline that allow it to burn cleaner. And limestone can be added to acidic lakes to cancel out the acidity to save guys like him. Greenhouse gas emissions consist of carbon dioxide, methane, nitrous oxide, and water vapor. Although greenhouse gases occur naturally in the atmosphere, the excessive amounts of it that we have in our atmosphere have been partially related to, through scientific research, to human activities such as the burning of fossil fuel and the deforestation of tropical forests. Serious climate changes may result from diverted ocean currents. For example, the Gulf Stream keeps Europe warm. If the stream is not running in Europe, then the temperature could be a lot cooler, which results in a drier climate, and so crops may not grow. Ecology changes on the land could include species of animals and plants extending their range to polar regions. So animals that cannot adapt to the different environment may become extinct. And sea life may also be impacted through the introduction of competitive species presently kept in other areas by water temperature changes and by failure to adapt to less saline water. Human society may be disrupted if changes in rainfall and temperature cause crop failure. Famine refugees will require significant humanitarian attention by the lucky nations, in other words, Canada. Okay, and as we should all know by now, sea levels may rise as a result of the polar ice caps in the Arctic melting, and as a result, low-lying land, like many Pacific Islands and Miami, will be underwater. Now, how do we, as a society, reduce our greenhouse gas emissions? Easy. We find an alternate energy source. There are tons, like nuclear power, hydropower, geothermal energy, and what was the last one? Solar energy. Nuclear energy relies on elements that can be split through a process called fission and will release part of their energy as heat. One of the elements most commonly used in the process of making nuclear energy is uranium-235. It is generally mixed with uranium-238 and produces plutonium-239 as a waste in the process. Special care must be taken so that the amount of plutonium doesn't accumulate to a point where it reaches critical mass, which is the amount of plutonium required to create a self-generated nuclear reaction. Fun fact, less than 8 kilograms of plutonium is required to make one Nagasaki-type bomb. Thus, in the year 2000 alone, enough plutonium was created to create 34,000 nuclear bombs. Nuclear waste can be generally classified as either low-level or high-level. Low-level nuclear waste usually include materials used to handle the highly radioactive parts of nuclear reactors and waste from medical procedures involving radioactive treatments or X-rays. Low-level waste is pretty easy to dispose of because the level of radioactivity and the half-life of the radioactive isotopes is relatively small. Storing the waste for a period of 10 to 50 years will allow most of the radioactive isotopes in low-level waste to decay, at which point the waste can be disposed of as normal refuse. Nuclear waste consists of mostly uranium and plutonium, and disposing of it is a completely different matter. It's much more complicated. The ideal action to get rid of it would be to just stop all nuclear production, find an alternate energy source, and then immobilize the waste. And through a verification process, the waste is combined with glass-forming materials and melted. Once the materials solidify, the waste is trapped inside and it can't be easily released. Now, this is the ideal method, however, it's not realistic because we are too dependent on nuclear energy as it is, very efficient at producing electricity. And so what we do instead is a process called transmutation. And that is the process of transforming one element into another. The goal of transmutation in radioactive waste disposal is to transmute long half-life, highly radioactive elements into shorter half-life, less radioactive elements. A specific method of transmutation that we currently use today is through the use of a hybrid reactor to produce a subcritical nuclear reactor, which basically stops all nuclear reactions and it bombards the nuclear fuel with neutrons. The neutrons break apart the large radioactive elements, which releases energy, and that energy is used to power the neutron source, which is needed to start the fission reaction. Hi, Miss Botticelli. I'd just like to apologize for putting you through this really painful presentation. I assure you, I did not have fun either. You must have been like,